Okay, in this lecture we will cover composition of functions and inverse function. First of all, composition of function. Let's you have two functions f and g. So this is composition function. This is not product. This is composition function. So one function is the input of the other function. Here f of g. This read as f of g. It means f is an outer function and then input of that outer function is another function g. So functions are like machines, so it's mean there are two machines and there is some x which is the input of the first machine, and then this first machine is in fact the input of the second machine. So the domain and similarly this one, so you can change the order of this machine. So g of f means g is the outer function, so x is the domain of f, is the input of f, and then the whole f is the input of g. And for domain if you see, x should be first of all in the domain of g. So for the domain of composition function f of g, so x first of all should be in the domain of g, and then this g should be in the domain of f. So then such that this g is in domain of f. Similarly for this one, for the second one, x is in domain of f and then f of x is in the domain of g. With the example, I think it will be more clear. And generally its f of g is not equal to g of f. So this is not true. Might be true in some cases, but usually this is not true. I mean, if you change the order of these functions, so the functions might be different. Let's do an example. Here you have to find both f of g and then you have to change its order, so g of f, and then you have to find their domain. First let's find f of g. So how do we find it? What is our f? Our f is this function. This is our f, x squared plus 3, and this is g. So our f is x squared plus 3. Okay, this is our f of x, and your g x is this one. So first of all, f of g, in f of g, f is the outer function and g is the inner function. And what is g of x? It's given, so we can replace the value of g of x here, square root of x. Now we will get this one, f of this thing. F of x, remember, it's given, and that was this thing, x squared plus 3. So but here you have to find f of square root of x. Instead of x you have this square root of x. So what you will do, on the right hand side of this function f, you will replace your x with that thing which is here. Here you have square root of x, not x. So you have to replace this x with this square root of x. So square root of x squared and then plus 3. This square with square root will be cancelled, so it will be x plus 3. So this is composition function f of g, when f is the outer function and g is the inner function. Let's do the other way. Here g is outer and f is inner. So first we will replace the value of f. So what is the value of f? X squared plus 3. Now we have g. Now we have to find g of x squared plus 3. So what is the function of g? This is g. Instead of this x here, now we have x squared plus 3. So what we will do, the same way that we did for f, on the right hand side of this g, instead of this x we will replace this whole thing. So instead of this x we will replace x squared plus 3 and this square root as it is. So just we replace this x with this whole thing and the other square root is its own place. Okay, so you see both answer are different, they are not same. So f of g and g of f might not be same. How about their domain? How we will find their domain? If you see what was the definition of domain, first you have to see which function is the inner. For example, in this case g is inner. First you have to find the domain of the inner function, and then you can see that what you have the answer. For example, this is our answer, f of g. Now you have to take such that this x, when you put x in g, so g should be a domain of f. So in simpler word you can say that first you need to find the domain of the inner function, and then you will find the domain of this answer, and then you will take their intersection. So what is the domain of the inner function? Inner function in this case is g. So my g is this one, square root of x. So what is the domain of the square root of x? Here you have, it's not a polynomial, so you cannot say that its domain is set of all real number. it's not rational function, it's the radical one. In radical, and since it's a square root, so whatever you have inside that square root, that thing should be greater than or equal to 0. So its domain is all positive numbers including 0 and positive numbers. Okay, this is the domain of the inner function. Now what is the domain of the answer? X plus 3 is a polynomial, and domain of a polynomial is set of all real line. So the domain of the answer is set of all real line, and the domain of the inner function is greater than 0. So this part. So what will be their intersection? Intersection means the common things. One is this whole thing, another one is only this part. So intersection will be this 0 till plus infinity, meaning x greater than or equal to 0. So that's why their domain is 0 till plus infinity. Similarly, let's find the g of f. We already found it. So now we have to find their domain. So what's the domain of g of f? Here the inner function is f. First you have to find the domain of the f, and this is f, and f is a polynomial, so domain is a set of all real line. And what is the domain of the answer? This is our answer. Okay, so what is this domain of the answer? Whatever you have inside this square root, that should be greater than or equal to 0. Okay, so this x square plus 3 is greater than or equal to 0, but this is always positive for every value. Why? Because of this square. So if you square a number, that number will be positive, and 3 is a positive number, and you are adding to positive number, of course this thing will be positive for every x. So this whole thing is positive for all x. So we can say that its domain is set of all real numbers. And the domain of the inner function, which was f, this is also a polynomial, so the domain is a set of all real line. So in the both case they are real line, so their intersection is of course real line. The whole real line, it's mean minus infinity till plus infinity. Similarly, you may have three functions. Here you see you have three functions: f of g of h, f of g of h. H is the innermost, so if you rewrite them, so it's like that. This thing is in fact h is the innermost, so h of x is always with the innermost. Okay, so x is in the domain of h because h is the innermost, and then h of x is the input of g. Okay, and then g of this whole thing is the input of f. So the outermost is f, and what is the input of f? Input of f is this thing, and this is g. And what is the input of g is h, and what is the input of h is x. So h of x is the input of g, and this whole thing is the input of f. So we will solve it in the same way as we did for 2. First we will replace the value of the innermost. H of x is given, which is x cubed. This one is given here, this is x cubed. We will replace it, and then we will find the value of g of x cubed. So g of x is this, so instead of x, now you have x cubed. So on the other side, right hand side, you have to replace this x with that thing, so that will be x cubed. So it will be 1 over x cubed. Now you have to find f of 1 over x cubed. So what is f? This is f, but instead of x you have this thing, so of course you will replace this x by this whole thing. Okay, remember, whatever you have inside that as an input, you have to replace that input in your original function on the right hand side instead of x only. The remaining thing will be as it is, the square root as it is. You just need to replace x with this whole thing, only x. For example, if you have x plus 2, so you just need to replace this x with this whole thing, and then this plus 2, and then square it as it is. Okay, let's do this example. Here your f and g are given. You have to find f of g of 2. G of 2. First let's find g of 2. Instead of x we need to replace 2, and here instead of x we need to replace 2. 2 cube plus 1, that will be 8 plus 1 9, so that is 9. So g of x is 9, so this whole thing will be 9, and then we need to find f of 9. So what is f of 9? F of x is square root of x. Instead of x you have to replace 9 on the right hand side of this function, so square root of 9 is 3. So then this is the answer. Okay, now the last topic of this lecture is the inverse function, and for inverse function, two functions are the inverse of each other, or we can say that one function is the inverse of the other one if you take their composition function in both direction. For example, if you have two function f and g, if I take their composition function in both direction, mean if I take the g as an inner function and then f as an inner function, their answer, and at their, for example here you see their answers are different. Here if you see in this example, this is x plus 3, but this one is x squared plus 3 square root, so they are different. But if these two answers are same, but not only same, if they are equal to x only, not x square or 2x or anything else, only equal to x means the input, whatever the input it is, so if the answer, the output is also the same, then we can say that these two functions are inverse of each other. Okay, and the notation for inverse is used by this is not the power, don't confuse it with this one, like this x minus 1 is 1 over x. Okay, this is the power, your x minus 2 is like this, but this is notation for inverse function. Whenever you have minus 1 on f, it mean inverse of f. So for example here, if g is the inverse of f, so we can say that this g of x equal to f inverse. It means g is the inverse of f, inverse function of f. And how to check if two functions are given, how to check these two are inverse of each other? As I said before, two functions are inverse of each other if their composition with both, in both order, their composition should be x, the answer should be x. So here if you see, if you take the composition function g of f is the inner and g is the outer, here this is the calculation, you can check it. So you will get the answer x, and if you change the order and if you do calculation, you will get x. So both are same, and x, not only same, they should be equal to x. So since their composition are same and they are equal to x, so we can say that this one is the inverse of f, or f is the inverse of g. Now similarly, this example you can check. Here you will see that the answer will be, in the first case 9x plus 2, in the second 9x minus 2, but their answer are not same and they are not equal to x, so these two are not the inverse of each other, they are not inverse of each other. Now in these previous two examples, both functions were given and you wanted to check that whether they are inverse of each other or not. But in the next example, we will see how to find the inverse. For example, only one function is given and you have to find the inverse of that function. So what is the criteria? The criteria is that first of all you have to replace f of x by y. You will replace f of x by y, and then you will solve it for x. Mean that you will find x, you will make x as a subject. So you will solve it for x, and then you will replace x with f inverse y, because when y is f inverse x, so of course f will be f inverse of y. So if you take y, f on the other side, so x is f inverse of y. Then you will replace x with f inverse y, and at the end you just replace y with x. Let's do it with an example. This is the function and you have to find its inverse. So remember, what was the first step? First step is replace f of x with y. Okay, we will replace this f of x with y, so we will get this one. The next step was solve for x. You need to find the value of x in terms of y. So in order to find the value of x in terms of y, first I need to banish this fifth root. So I have to take power 5 on both sides. So if I take power 5 on both sides, this fifth root will be cancelled, and this will be y5 equal to 4x plus 2. Since I need x, so I will shift 2 on the other side, and then I will divide by 4. Now if you see that this is x in terms of y, so this will solve for x. So that was our second step. What was the third step? Third step, you have to replace x with f inverse y. Okay, you need to replace this x with an f inverse y, so you will get this thing. And the last step, you just need to replace y with x. So now this is the inverse function, and now you can check it. I don't know here it checked or not. No, it didn't check it. Here you have to check it also. I mean, this is f and this is f inverse, and you need to check your answer, that is it correct or not. Maybe you did a mistake, or maybe the f inverse, the inverse of f is not this. So how you will check it, that how you will sure that these two are inverse of each other? You will take their composition. If their composition in both direction equal to x, then it's inverse function. So I will do one side, and you can check it by yourself the other side. Here I took f inverse inner function and f as outer function. So first I need to replace the value of my this f here. So x5 minus 2 over 5. Now I need to replace this value in f. So this f, what is f? 4x plus 2 cube root. So instead of x, I need to replace this whole thing instead of x. So instead of x, x5 minus 2 over 4. This is just instead of x, and the rest of things as it is. So here you see 4 will be cancelled with this cancelled with this, and this cancelled with this square root. So the answer is x. Similarly for the other order, you can check it. So, and there is a just simple even function and odd function, and then next graph of a function is a part of our next lecture. So you just let's cover even function. Any function is an even function if you replace x with minus x and the answer doesn't change. Okay, for example, x squared, if you replace x with minus x, so it will be minus x squared, it will be again x squared, and the x squared was in fact our original function f of x. So our function doesn't change. So these are even function. Cos x is also an even function. Cos and its reciprocal are even function, but rest of the trigonometric functions are odd function. Odd function is a function if you replace x with minus x, the function changes, but the change is only in negative sign. मीन कि अगर आप negative sign common ले लोगे तो वो वापस जो बाकी का फंक्शन है वो वही फंक्शन होगा जो ओरिजिनल फंक्शन है, मतलब बाकी और कोई चेंज नहीं है, ओनली ना माइनस साइन. फॉर एग्जांपल यहाँ पर देखो एफ ऑफ एक्स इक्वल टू, अब यहाँ पे अगर मैं एक्स को माइनस एक्स से रिप्लेस करूँ, एक्स को माइनस एक्स से, माइनस को मैं बाहर ले आऊँ माइनस 2x. अगर आप देखो माइनस साइन अगर बाहर है तो बाकी का जो पार्ट है वो एग्जैक्टली वही ओरिजिनल फंक्शन है. ठीक है, द ओनली चेंज इज़ नेगेटिव साइन. सिमिलरली हियर ऑल ऑफ द ट्रिगोनोमेट्रिक फंक्शन जो होते हैं वो ऑड फंक्शन होते हैं एक्सेप्ट कॉस ऑफ एक्स एंड इट्स रेसिप्रोकल विच इज़ सीकेंट एक्स. बाकी सारे ऑड होते हैं. ठीक है, आपने 101 में भी पढ़ा था कि साइन ऑफ, जिस तरह साइन ऑफ माइनस एक्स, अगर आपको याद हो, वहाँ पे हम कहते थे साइन ऑफ माइनस एक्स इज़ नेगेटिव साइन ऑफ एक्स कहते थे. ठीक है, लेकिन कॉस ऑफ माइनस एक्स को हम कॉस ऑफ एक्स लिखते थे. जैसा कॉस ऑफ माइनस 30 डिग्री है तो उसको, या कॉस ऑफ कोई माइनस π/4 है, कुछ भी है, तो हम उसको कॉस ऑफ π/4 ही लिखते थे. बट साइन ऑफ फॉर एग्जांपल माइनस 30 डिग्री को हम लिखते थे माइनस साइन ऑफ 30 डिग्री. ठीक, सो देन द ग्राफ थिंग वी विल कवर इन द नेक्स्ट लेक्चर.